Welcome back, everyone. On today's agenda, we're going to go ahead and finish the last problem from the notes last week. We have some notes today on angles, and then at the very end of the lesson, there's a Google form. By the end of class today, you should be able to find the measurements of angles in a circle. So we have this problem that states the moon's orbit is not exactly circular, but the average distance from its surface to the Earth's surface is 384,000 kilometers, and the diameter of the moon is 3,476 kilometers. Find the distance from the surface of the Earth to the visible edge of the moon if the moon is directly above the observer. Figure not drawn to scale. Okay, so we're given some information from this problem that we're going to go ahead and add to the image. So I'm given that the diameter is 3,476 kilometers. So remember, diameter describes the whole distance going from one end of your circle, passing through the center of your circle, and then touching the other end. Okay, so that diameter, we're going to go ahead and we want to find the radius for this problem. So remember, the radius is half the diameter. So I'm going to go ahead and I'm going to take half of that diameter, and that's going to give me 1738 kilometers. Okay, and then I was also given in the problem that the moon was directly above the observer. Okay, so that's a key component because then that tells me that this angle here is going to be a right angle. So since this is a right angle, I'm looking at a right triangle. So to solve for that missing length of this side here, I'm just going to go ahead and use the Pythagorean theorem. So this is my value of x, and remember your right angle always points to the hypotenuse, so it's going to be my c. I'm going to make this, I'm solving for my a, and then I know my b. So my a is x squared plus 1738 squared is equal to, and then I'm going to take the value of the length that I have here that's given, 384,000, and I'm going to add to that though the length of the radius because I need my full hypotenuse length. So I'm going to do 384,000 plus 1738, and then I'm going to take the sum of that and square it. So once I do that, I get this equation here, and then we solved these problems before. I just went ahead and I subtracted the 3,020,644 from both sides, and then I took the square root of it, and that got me approximately 385,734.1 kilometers. Now we're going to go ahead and talk about angles and arcs. So when we're looking at a central angle is an angle whose vertex is the center of the circle. So notice my vertex of this angle, AOB, is right at the center of my circle, my point O. And that angle that's formed there, we're going to call that the central angle because it's coming from the center of the circle. Now, the measure of a minor arc is the measure of its central angle. So we basically just call an arc a minor arc when it is the smaller arc of whatever two arcs that you have within your circle. And so here, if we have our central angle, notice this arc is going to be smaller than, so if I say angle AOB, that's my central angle, that arc that's formed by it is smaller than that arc of the other side of the circle. Okay, so if I'm looking at angle AOB versus that arc of going from A all the way to B on the outside, obviously this degree of this angle is significantly smaller than this degree of this angle here, or that arc. So the measure of a major arc is always 360 minus the minor arc. So again, we have this arc here, the central angle, 79 degrees, because it's, remember, touching that center point of your circle B, and it formed the angle CBA, and we have that its degree is 79 degrees. That means that this arc is 79 degrees, that arc of C to A, okay, or AC. Now, we know for certain that circles always equal 360 degrees. So if we know that this angle here is 79, what we just want to do is take 360 and subtract 79 degrees, and that would give us the measurement of this arc here, which is our major arc, or arc CDA. So, or going the other way around, ADC. So arc ADC is our major arc,